Hello friends, this video on equilibrium part 23 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Let's take some questions now. So we are decreasing the pressure by increasing volume and want to find which direction will flow. This guy has 2 moles, this guy has 1. So if you decrease the pressure is decreased, it will go to move towards more number of moles. Correct? See, pressure is increased, it moves towards less number of moles. Pressure is decreased, it moves towards more number of moles. So in this case, it will move here. Let's take this part you can ignore. This has 1, this has 0, so this has more. So it will move towards this. Talk about this reaction. In this reaction, we have this ignore. So we have 4 here, we have 4 here. There is equal number of moles of gas in the reacting product, so there is no effect. No effect of change in pressure. Let's take one more example. The question says how will the reaction be impacted by increasing pressure. So here pressure is increased, and also mention whether it will go in forward or backward direction. So let's start with 1. Let me number here 1, 2, 3, 4, 5, 6. Let's take 1. So 1, we have 1 mole here and we have 2 moles here. So if pressure is increased, it moves towards less number of moles. So which side has less number of moles? This side. So it will move in this direction. So it will move in the back direction. Let's take 2. So we have solid, we have 1 plus 2, 3 moles here. We have 1 plus 2, 3 moles here. Both sides 3 moles, so no effect. Let's take third. So we can ignore the solid part. So we have 1 mole here and we have 2 mole here, right? 1 mole here and 2 mole here. So it will move in this direction to the lesser number of moles direction. So it will move in the back direction. Let's take 4. We have 2 plus 1, 3 moles here, we have 1 mole here. So it will move in this direction if you increase the pressure. So it will move in the forward direction. Let's take 5th. Solid you can ignore. So we have 1 mole here, we have 0 mole here. So obviously it will move in this direction, the less number of moles direction. So it will move in the back direction. Let's take 6th. So we have 5 plus 4, 9 moles here. Here we have 6 plus 4, 10 moles here. So which one has less? This guy. So it will move in the less direction if you increase the pressure. So it will also move in the back direction. So that is my answer. Correct. The equilibrium constant for the following reaction is 1.6 into 10 to the power 5 at 1024 Kelvin. The reaction is H2 plus hydrogen plus bromine gives 2 HBr. We have to find the equilibrium pressure of all gas if 10 bar of HBr is introduced in the sealed container at 1024 Kelvin. So I have this reaction H2 plus Br2 gives 2 HBr. T is equal to 0. We have 10 bar here. We have 0 and 0 bar pressure here. Right? T is equal to equilibrium. So let's suppose it has reduced P bar. So it will create P by 2 bar and P by 2 bar. Why? Because it is 2 here, it is 1 here. Correct? The equilibrium constant is known. Kp is known. This is Kp actually. So Kp is what? It will be pressure of HBr square by pressure of H2 and pressure of Br2. Correct? So this is nothing but 10 minus P square by P by 2 square. Correct? And this is nothing but 1.6 into 10 to the power 5 given. You solve this, you get P is equal to 10 by 201 bar. Once I have the value of P, I have all the concentrations or equivalent pressure. So pressure of H2 is what? P by 2. That is 10 by 201 into 1 by 2 It's almost equal to 2.5 into 10 to the power minus 2 bar. Similarly, pressure of H2 will also, Br2 will also be equal to same. So I'll just write, it will be same as H2 only, P by 2. We talk about pressure of HBr, that is nothing but 10 minus P. That is 10 minus this value, 10 by 201. That's almost equal to 10 bar. So this is my answer. Easy one. So you just have to use the same way. Initial concentration of HBr was 10. At equilibrium it is 10 minus P, is P by 2 and P by 2. Write the equation for Kp, solve for value of P, and we get all the answers. So dihydrogen gas is obtained from the natural gas by partial oxidation. It's an endothermic reaction. This is the reaction given. We have to find the equation of Kp. Let's find the equation of Kp. That will be nothing but pressure of CO into pressure of H2 with power 3 divided by pressure of H2O to pressure of CH4. This will be the value of Kp. So the next question says that what will be the effect of Kp when the pressure is increased? So when I told that pressure increased, it goes to less number of moles side. So this guy has 1 plus 1, 2 moles, this guy has 4 moles. So less number of moles is this side, so it will go in backward direction. That is part 1. Part 2, temperature increase. Since this is endothermic reaction, that means you give heat. CH4 plus O2, sorry, H2O plus heat, this gives CO plus CH2. Since you give heat, then this is endothermic reaction. To increase the temperature, what will happen is, it will go in this direction. Correct? Forward direction. Why? Because if you increase the temperature, the system will move in such a way that it will counter effect the increase of temperature. It can do only by going in this direction, because in that direction the heat is consumed and the temperature of the system goes down. Using catalyst. Using catalyst, rate of reaction will increase. Will increase or decrease, I'm not sure. Will increase or decrease, but no change in Kp. Okay. One more thing, when you increase the pressure, Kp is not changed. Kp is not changed, but here Kp is changed. As I told, right, Kp is changed only when you increase or decrease temperature. Here Q is changed. Here Q is not changed. Correct? So in this case the Kp will not change. Pressure increase, Kp will not change, but the reaction moves in the backward direction because the Q change. When temperature is increased, Kp is changed and the reaction moves in forward direction and the Q doesn't change. When you add catalyst, the rate of reaction may go up or down. Mostly it goes up, but the Kp is not changed and Qc is also not changed. There is no change in equilibrium. Describe the addition of H2, addition of CH3COH, removal of CO, or removal of these from this reaction. So let me write this reaction. 2H2 plus CO gives CH3OH. Right? So if you add H2 here, what will happen? The reaction will go in the forward direction. So this will go in the forward direction. Done. If you add CH3COH, what will happen? The concentration of CH3COH will increase. The reaction will move in such a direction that it will decrease this reaction, the concentration. So reaction will move in this direction. So it will move in the backward direction. Okay. You remove CO. If you are removing CO from here, what will happen is reaction will move in such a direction that it will bring more CO. To bring more CO, the reaction will move in backward direction. Correct? See, if you remove CO from here, the reaction will move in such a direction that it get back CO. To get back CO, the reaction should move in the backward direction. To remove CH3COH, let me again write this reaction because that is dirty. So if you remove this CH3OH, what will happen? Reaction will move in such a direction that it will generate more CH3COH, that it will go in the forward direction. And that is my answer. At 473, the equilibrium constant for the decomposition of phosphorus pentachloride PCl5 is 8.3 × 10⁻³ Kc at 473 Kelvin. If the decomposition is depicted as this is the reaction, PCl5 gives PCl3 plus Cl2 and delta H is 124, that is plus 124 endothermic reaction. To write the reaction for the first thing is we write Kc for the reaction. So let's first write Kc. Kc will be what? Concentration of PCl3, concentration of Cl2 divided by concentration of PCl. That is Kc. First part is done. Second part, what is the value of the Kc for the reverse reaction? So just flip this, will be 1 by Kc. That is nothing but PCl5 concentration divided by PCl3 concentration and Cl2 concentration. Okay, this part is done. What would be effect of on Kc if more PCl5 is added? So let me write this equation once again here. Plus Cl2, and this is, since it is plus 124, you need heat here. Okay. So you add more PCl5, what will happen? The concentration of PCl5 goes up, the reaction moves in such a direction that the concentration of PCl5 should decrease. That means the reaction moves in forward direction. So reaction moves in forward direction. Pressure is increased. So if pressure increase, the reaction moves in direction of pressure increase, direction moves in the direction of direction is equal to less moles. Right? It moves toward the less moles. So here we have 1 mole, here we have 2 moles. So it moves in the backward direction. Right? Pressure increase, it moves in the backward direction, but Kc will not change, Qc will change. Correct? Here also concentration Kc is not changing, but Qc will change. Third was temperature is increased. So since it is an endothermic reaction, if you increase the temperature, reaction will move in such a direction so that the whole system cools down, right? So that the system will move in forward direction. And also here Kc will change, Qc will not change. Correct? Hope you understand why I have done this, why Kc is changing, why Qc is not changing and all this thing in the past few slides. So if you don't understand, watch the previous few slides in the same chapter where we explain why Kc change sometimes and why Qc change sometimes. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.